Our galactic address, the local group. We live on a planet called Earth. This blue and green sphere is our home, teeming with life and diverse ecosystems. From the vast oceans to the towering mountains, Earth is a unique planet in our solar system. Earth orbits a star called the Sun. The Sun is a massive, glowing ball of hot gases, primarily hydrogen and helium. It provides the energy necessary for life on Earth, driving our weather, climate, and the photosynthesis process in plants. Our Sun, along with hundreds of billions of other stars, forms a vast, swirling galaxy known as the Milky Way. This galaxy is a barred spiral galaxy, with its stars, planets, and other celestial objects orbiting around a central bulge. But did you know that the Milky Way itself is just one of many galaxies in our cosmic neighborhood? There are countless other galaxies, each with its own unique properties and characteristics, scattered across the universe. Astronomers call this neighborhood the local group. This group is a collection of galaxies that are gravitationally bound to each other, meaning they influence each other's movements and positions in space. It is a collection of over 50 galaxies bound together by gravity, spread across a vast expanse of space, roughly 10 million light-years across. The two largest and most well-known galaxies in the local group are the Milky Way and the Andromeda Galaxy. The local group is our galactic address, a cosmic community where galaxies interact and evolve. These interactions can lead to spectacular events such as galaxies merging or triggering bursts of star formation. Understanding the local group helps astronomers learn more about the universe's structure and the forces that shape it. The Milky Way, our galactic home. This vast and magnificent galaxy is where we reside, a cosmic neighborhood filled with wonders and mysteries waiting to be explored. The Milky Way is a barred spiral galaxy, one of the billions of galaxies in the observable universe. It stretches over 100,000 light-years in diameter, containing hundreds of billions of stars. A majestic structure of stars, gas, and dust, the Milky Way is a testament to the grandeur of the cosmos. Its spiral arms are like celestial highways, guiding the movement of stars and interstellar material. Imagine a flat disk with spiral arms, each arm a swirling stream of stars and cosmic dust. These arms wind outwards from a central bulge, a dense region packed with older stars. This central bulge of stars is a bustling hub of activity, where stars are born and die in a continuous cycle of creation and destruction. Surrounding the galaxy is a halo of faint stars and mysterious dark matter, an enigmatic substance that makes up most of the universe's mass but remains invisible to our eyes. Our Sun resides in one of the spiral arms, specifically the Orion arm, a relatively minor arm of the Milky Way. This is our cosmic address in the vast expanse of space. About 26,000 light-years from the galactic center, our solar system orbits the Milky Way at an average speed of 828,000 kilometers per hour, taking approximately 230 million years to complete one orbit. From our vantage point on Earth, we see the Milky Way as a band of light stretching across the night sky, a river of stars too numerous to count. This band is the combined light of millions of distant stars. Within this river of stars, there are dense star clusters, regions where stars are packed closely together, creating a dazzling display of light and color. Our galaxy is a dynamic place with stars being born, living out their lives, and eventually dying in spectacular supernova explosions. These events are not just endings but also beginnings, as the remnants of these explosions seed the galaxy with the elements necessary for new stars and planets to form. Supernova are among the most powerful events in the universe, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. They are the cosmic forges where elements heavier than iron are created, enriching the interstellar medium with the building blocks of life. Andromeda, the Milky Way's giant neighbor. The most massive galaxy in the local group is not our own Milky Way but our neighbor, the Andromeda Galaxy. Andromeda, also known as M31, is another spiral giant located about 2.5 million light-years away. It is a breathtaking sight in the night sky, visible to the naked eye in dark locations as a faint, fuzzy patch of light. Andromeda is on a collision course with the Milky Way. Don't worry, this cosmic collision won't happen for another 4 billion years or so. The Magellanic Clouds, our galactic companions. Orbiting the Milky Way are two smaller galaxies, the Large Magellanic Cloud and the Small Magellanic Cloud. These irregular galaxies are visible to the naked eye from the southern hemisphere, appearing as detached pieces of the Milky Way. The Magellanic Clouds are actively forming stars, fueled by vast reserves of gas and dust. These galactic companions provide astronomers with nearby laboratories to study star formation and galaxy evolution. Beyond the Big Three, a tapestry of dwarf galaxies. While the Milky Way, Andromeda, and the Magellanic Clouds are the most prominent members of the local group, they are far from alone. Our galactic neighborhood is teeming with smaller galaxies, known as dwarf galaxies. These dwarf galaxies come in various shapes and sizes, from dwarf ellipticals to dwarf irregulars. Some dwarf galaxies, like the Sagittarius dwarf spheroidal galaxy, are being torn apart by the Milky Way's gravity. These galactic interactions provide clues about the formation and evolution of galaxies. Gravity is the master sculptor of the universe, and its influence is evident in the interactions between galaxies in the local group. Galaxies are not static islands in space, they move and interact under the relentless pull of gravity. Sometimes these interactions can be dramatic, leading to galactic cannibalism. Larger galaxies, like the Milky Way, can pull in and merge with smaller galaxies, absorbing their stars and gas in a process that can take billions of years. Dwarf galaxies may be small, but they are incredibly important for our understanding of the universe. These galactic dwarfs are thought to be similar to the first galaxies that formed after the Big Bang. By studying dwarf galaxies, astronomers can gain insights into the processes that governed galaxy formation in the early universe. These galaxies are like cosmic fossils, preserving clues about the universe's infancy. Our understanding of the local group has evolved dramatically over the centuries. Early astronomers were unaware of the existence of galaxies beyond our own Milky Way. It was only in the 20th century, with the advent of powerful telescopes and the work of astronomers like Edwin Hubble, that we began to unravel the true nature of our galactic neighborhood. Today, with advanced telescopes and computer simulations, we are able to study the local group in unprecedented detail, uncovering its secrets and complexities. The study of the local group reminds us of our place in the vastness of the cosmos. This collection of galaxies, including our own Milky Way, Andromeda, and dozens of smaller galaxies, forms a gravitationally bound system. It is a small but significant part of the larger cosmic web that stretches across the universe. By examining the local group, we gain insights into the formation and evolution of galaxies, the distribution of dark matter, and the nature of cosmic expansion. We live on a small planet orbiting an ordinary star in a galaxy that is just one of trillions in the observable universe. Our Milky Way is a barred spiral galaxy, home to billions of stars, planets, and countless other celestial objects. Despite its vastness, the Milky Way is just a tiny speck in the grand tapestry of the cosmos. Each star we see in the night sky is a part of this intricate structure, and many of them have their own planetary systems, potentially harboring life. Yet despite our cosmic insignificance, we are privileged to live in a time when we have the tools and the intellect to explore and understand the universe around us. Modern telescopes, both ground-based and space-borne, allow us to peer deep into the cosmos, revealing the wonders of distant galaxies, nebulae, and star clusters. Advances in technology and science have enabled us to map the cosmic microwave background, detect gravitational waves, and even capture the first image of a black hole. The local group is our cosmic backyard, a place where we can study the intricate dance of galaxies and unravel the mysteries of the universe. By observing the interactions between galaxies, such as the impending collision between the Milky Way and Andromeda, we can learn about the forces that shape the cosmos. These studies help us understand the life cycles of galaxies, the role of dark matter, and the ultimate fate of the universe. In this grand cosmic dance, we find not only our origins, but also our future. Stay curious and keep exploring the wonders of the universe.